All right, so we have the Greek prefix naming system, which is slightly antiquated, but it is used with multiple oxidation states with nonmetals. So we're looking for multiple oxidation states with the nonmetals. The prefixes, as we talked about with hydrates, those are the words that indicate the number of each of the elements, and they are the same ones from when we did the hydrates. Sorry about that. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So remember, these 5 through 10 are found on reference table P under the organic names, but 1, 2, 3, and 4 are different from the organic names. So how do we name it? So you take a look and you say, okay, if the first element has a subscript, you don't need a prefix. Any other number besides 1, if the first element has a 1 as a subscript, no prefix is required. Any other one requires one of those prefixes we listed before, and the prefix tells you the number of atoms. And then the same rule for the second one. So if we have this compound, notice that the first element has a subscript of 1, which is not written. So that would just be carbon. Also notice that we're dealing with 2 nonmetals here, carbon and chlorine. So there are 4 chlorines, so the prefix for 4 would be tetra. And then ending up the compound would be chlorine becomes chloride in a binary compound. Carbon, tetra, chloride. Now, we could also name this a different way using the stock system, which would be, I believe, carbon Roman numeral 4 chloride, but that is a different naming system. This is the Greek naming system. So once again, we have the first element has a subscript of 1, so it's just going to be phosphorus. And then we have 3 bromines, so that's going to be tri, and then we end it with bromide. Phosphorus tribromide. So when we're writing our formulas, we're just going to go from the reverse. Those prefixes are going to help us tell the number of atoms. If the first element has the prefix, it corresponds to the atom. Again, if we don't have a prefix, assume that the subscript of 1. So this doesn't represent oxidation states or crisscrossing. It just tells you literally the number of atoms in your formula. And the same thing for the second. So when it says dinitrogen, that's going to be nitrogen, 2 of them. Pentoxide, oxygen, pent meaning 5. So we're not going to crisscross, we're not going to do anything like that. This prefix tells you the number of atoms. Carbon monoxide, this is a common one. So 1 carbon, since there's no prefix before it. Mono, meaning 1, so monoxide, CO. So that's carbon monoxide, that toxic gas. Carbon dioxide would be CO2, 2 oxygens. So the Greek naming system, not on the Regents. We do see this system in naming compounds that we see around. Generally, though, on the Regents, we talk about the stock system with the Roman numerals. All right, thanks for watching.